Hello. Well, it's time to get ready for the final exam. Now, remember, we studied college algebra, and this is the algebra using the real numbers and sometimes the complex numbers. Define the real numbers. The real numbers are all the rationals and all the irrationals. Well, I define real numbers using two terms, rational numbers and irrational numbers. So, to make it clearer, I need to define those two terms that I used to define real numbers. But again, real numbers are all the rational numbers and all the irrational numbers. The rational numbers are the numbers that can be written in the form P over Q, where P and Q are integers. What are the integers? Well, 0, 1, 2, 3, 4, dot, 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 -1, -2, -3, -4, dot, 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 infinite. The rational numbers are in the form of a fraction, a numerator, fraction line, and a denominator. The P is a rational number. The P is an integer, and the Q will be an integer. So numbers such as 1/2 or 2/3 will be called rational numbers. And whole numbers are rational numbers because you can write the whole number over the denominator 1. 4 can be written 4 over 1. So all whole numbers are rational numbers. What are the irrational numbers? They are non-repeating, non-terminating decimals. Irrational numbers are numbers such as pi or e or several more, many more actually. You can do research on that. The irrational numbers cannot be written as a fraction exactly. They can be approximated by a fraction. For example, pi is an irrational number, 3.14, but it goes on and on with no pattern. The decimal part of it, non-repeating, non-terminating. So again, my real numbers are all the rationals and all of the irrationals. Now, once I define the universe of numbers I'm working with, I should define my operations. The four basic operations that we do are adding, subtraction, multiplying, and dividing. The operations are called binary operations because it takes at least two elements to carry out the addition, the subtraction, the multiplication, and the division. So the universe of numbers we're working with are called real numbers. The binary operations that we master are addition, subtraction, multiplication, division. Next thing, real numbers are comparable. You can compare. You can say A is less than B, or you can say A is greater than B, or A is equal to B. We call those three ways of comparing a trichotomy. The real numbers are comparable. You can compare two real numbers. You can decide which one is larger than the other, which one is smaller, and whether they're equal or not. Okay? Now, there are properties that we must learn, or laws. What are the laws? Well, here are a few examples. The commutative law, A plus B is B plus A. The multiplicative identity, 1 times A equals A. The additive inverse, A plus 0 equal A. The distributive law, A times the quantity B plus C is AB plus AC. You read that usually from left to right, but if you read it from right to left, it's the factoring. If you have AB plus AC, it equals A, open parentheses, B plus C, close parentheses. So the distributive law is the basis by which we factor things. To factor means to write as a product. Other laws that we have, reciprocal. If you have 3, the reciprocal is 1/3. If you have 2/3, the reciprocal is 3/2. Now, a number times its reciprocal is always equal to 1, the multiplicative identity. Then you have opposites or additive inverses. 3 has an additive inverse, -3. 3 plus -3 equals 0. You must learn your properties. You have the associative law. A plus the quantity B plus C equals the quantity A plus B plus C. In other words, A plus open parenthesis B plus C close parenthesis is equal to open parenthesis A plus B close parenthesis, plus C. In other words, you can shift the parentheses around three numbers and get the same answer. That's called the associative law for addition. We also have the associative law for multiplication. Look those laws up. So we start with a set of numbers, the real numbers. We identify our binary operations. We identify our laws that govern how we do what we do. And then we have what we call equations. If you have A equal B, that's an equation. The left member is A, the right member is B. Now, here's what you know about equations. If A is equal to B, then you can add the same thing to both sides of an equation. A plus C equals B plus C. You have symmetry. If A is equal to B, then B is equal to A. You have transitivity. If A is equal to B and B is equal to C, then A is equal to C. You have equations. Equations are identified. The left member is separated from the right member with an equal sign. We also have something called inequalities. If A is greater than B, that's an inequality. If A is less than B, that's an inequality. If A is greater than B, that's an inequality. We call the statement an inequality when the greater than sign, less than sign separates the left from the right member. Or if you have A greater than equal to B, that's an inequality. If you have A less than equal to B, that's an inequality. You can also transform inequalities. You can add the same thing to both sides of an inequality. You can subtract the same thing from both sides of an inequality. However, you have to be careful with an inequality when you multiply by a negative number. If you have A less than B and C is negative, and you want to compare AC with BC, it becomes AC greater than BC. Think about it. 3 is less than 4. But when you compare a negative 3 with a negative 4, what do you know? Which one is less than? The one with the larger magnitude. Minus 4 is less than negative 3 because minus 4 is farther away from 0. Well, it's so much you need to review, but this is just the beginning, a reminder of the algebra of real numbers. And of course, we will learn something called complex numbers. Okay, I'll come visit with you again.